In the next task, task 5, let's learn about the override function. Again, please copy task 4 to task 5. You will often want to the one of the number in the database. For example, if you want to change cooling period of spent fuel before reprocessing to from 3 year to 10 year, you can change original database in NMB, but this is not recommended because if you change one value in the original database, all the calculations will be affected. Anyway, the first thing to do is find the target value 3 year in database. This is written in the predefined data sheet. Predefined reprocessing. And predefined UO2 plutonium. This is same to the name of reprocessing plant. Here. And here you see number 3. A cooling term is defined for several type of spent fuel. And let's change all 3 numbers to 10 year. For that purpose, please copy this line to your input sheet. So copy to N is good position. And also copy the original data below. And you can change freely in your sheet. So let's change to 10, 10, and 10. Oh, sorry. Okay, let's run and see what happens. Okay. If you look into the reprocessed amount here, the reprocessing begins from 2011. So in task 4, it was 2004. So here is 7-year delay because you add 7-year cooling. And this is the final task, task 6. Okay, I copied. And in this task, we want to construct a FBR after light water reactors by using plutonium from light water reactors. And we also prepare the reprocessing dedicated for FBR. Let's start FBR from 2033 for 40 years, but I don't specify the capacity now. And we want to estimate the appropriate capacity. Okay. So at first, this is the name of FBR with high breeding ratio. Breeding ratio is 1.2, I think. So E2 2033. So B40 cells FBR underbar high breeding for 40 years. And as the first guess, please use 0.5 gigawatt electricity. And also we need reprocessing for the FBR. The name is MOX with plutonium recovery. MOX, like this. And the annual throughput is 27 ton. Until the end. And let's okay, and let's run the NMB. In this case, please concentrate to this report window dialog. Here, construction was success for PWR and destruct. Here you see the failure of the FBR construction. And as a result, FBR didn't construct it due to plutonium shortage. But we can conserve the message in dialog in the output sheet by using this output string. Okay, and please copy information. Sorry, I missed the keyword. Oh, here it is, at the end. Copy and paste in the bottom. For example, A93 and run again. Okay, the message in the dialog was printed here. And here is in the A113, you can see fail due to plutonium shortage. So this means 0.5 was too large. Let's change this to 0.25. So half. And let's run again. Okay, here you see the construction of FBR was successfully done. Oops. We had to add columns for power generation. 3 and print fuel 3 and I also recommend to add print plutonium 20. So please move this output string to BJ. Okay. So at first, let's check the electricity generation. As you see, from 2033, FBR begins to produce. And the plutonium mining is not required for FBR, so it is 0. And finally, let's see the plutonium inventory. Plutonium inventory was 1.4, around 1.4. No. Yes. And it increases gradually by FBR. And such kind of area graph is convenient to check the result. Let's make it. Please select the range from AI to BT and make graph. Graph should be area accumulated. Oops. Oh, sorry. Please select the AL to BT. Oops, sorry. AO. Okay. And this yellow is plutonium in the PWR spent fuel. And the brown is plutonium in MOX. This is accumulated until the beginning of FBR. And the green is storage of plutonium. Gray is plutonium in the MOX in FBR, and this is in the spent fuel cooled before reprocessing. And finally, this is in the spent blanket or breeding blanket. As you see, before the FBR introduction, plutonium inventory was around 4 tons, and it gradually increases up to 5.5 tons. Okay, this is the end of the this lecture, and please enjoy to change these tasks that is fit to your own scenario. Thank you.